Hello world. So today we are going to take a look at something really interesting when it comes to Angular's dependency injection, mostly when you want to create utility functions. Examples of utility functions are those functions which you want to reuse across your application. An example of a utility function is token validation, and another example is routing in the application, where you don't want to keep on injecting the router, or you don't want to keep on injecting the token validation service. You may be wondering, we already have run in injection context, which is provided by Angular. But what if there was another way to actually use dependency injection in functions, not in classes, but in functions? Because functions are really lightweight. When it comes to programming, you realize that functions, they are so small to the point that they are so easy to test, yeah? And if you write pure functions, then your work will be so easy. In the end, you are going to have an easy to maintain code base, as opposed to going with the approach of large classes, because with large classes, chances are it's going to be a bit tricky to test, if not like fully covering all the test cases. But with functions, you just write a small piece of code, then you can test it in isolation. All right, so let's get started by defining what a closure is, so that you may have a basis and go forward from there. So a closure is a function which wraps another inner function and shares its scope with the inner function, so that the inner function is able to access all that is in the outer function. However, the outer function cannot be able to access that which has been defined in its inner function. So let's see that with a very simple example. If we take a look at this piece of code, we have two functions. The first one is the outer function. Then we have an inner function. In this case, we have a constant a defined in the outer function, and then we have another constant b defined in the inner function. So if we log constant a in the inner function, we should be able to see it. But if we try and log constant b in the outer function, it can't work, because it has been enclosed within the inner function scope. However, constant a is shared between the outer function scope and the inner function scope. So let's see what happens when we try logging them out. So when we attempt to run this code, we should get an error because b is not defined. Why is b not defined? The log error that we are getting is for this part here, b in outer function. So b does not belong to the scope of outer function. It only belongs to the scope of the inner function. However, if we remove this piece of code, we should now be able to have a in outer function as 1, 2, 3, a in inner function as 1, 2, 3, and b in inner function as 4, 5, 6. All right. So that's how we have created scopes for different parts of the functions. And then you notice, for us to be able to get result from the inner function, we simply call it as we did the outer function. Okay, so that means then it is also possible to return a callable inner function from our outer function. So this is what we are going to do. We have changed our return value for the outer function to be the inner function. So when we call our outer function, we will only get this part. And the reason is the inner result that has been returned, since it's a function, it needs to be called. So when we run this function, we should only see a in outer function. However, when we call the return result of the outer function, we should be now getting a in outer function, a in inner function, b in inner function, as we did before. So what we have seen is that in as much as we can create different scopes for the functions, in this case inner and outer function, we can actually return the inner function from the outer function, so that later on it's going to be possible for us to reuse that which was created in the outer function in the inner function. So let's see what happens when we actually get to call this outer function multiple times, and that means we are going to have to change and assign our outer functions to a parameter. So we have just changed this part of code, and now we should get the results that we are getting before. So what happens when we now call this multiple times? As we said, we say we call it that much. So we should be getting a in outer function, a in inner function, a in inner function. Everything else now will be in the inner function. As you can see, the outer function is only called once when the wrapper, in this case the outer function, has been called, and then later on whatever is called is what is inside the inner function, as we have seen. So using this logic, we can see how it's going to be possible for us to create an injection context, yeah, in the outer function, and then use the injection context, or rather the dependency injection tokens that were created in the outer function in the inner function to do that which we want to do. So let's move over to our utility functions and see how we can apply the same closure logic in the utility functions. Okay. If we look at our browser, we see we have a nice looking UI here, whereby a user can click go to profile, then there will be a countdown, then they can be sent to the profile page. Let's see if it works, and then we will see what happens, or what the error that you are going to get will tell us. Yeah. So the error that we are getting is that inject must be called from an injection context. So what did we do wrong? Let's look at our code and see what we actually did wrong. So if we look at this code, we see that everything is okay. Yeah, it seems okay, but is it? Actually, it is not. Why is it not right? Because how we are calling our app router utility, we are calling it in a place that is not within the injection context. And in this case, that place is our go to profile. So we have this method that is invoked when the user clicks the button that you just saw. And then this method goes ahead and calls our app router utility with the parameters that we have passed in. So if we look at our app router utility, we should see that it accepts this command and that extra command, but the important part is this part here, where we are trying to instantiate, or rather we are injecting the router in this utility function, and then this will cause the error, because as far as Angular is concerned, nowhere has this inject, yeah, being called within an injection context. That means we have to actually prepare the right injection context before we can actually be able to use router.navigate. So let's see the changes that we need to make so that our code can actually work as expected. The first thing that we have done is that we have modified our app router utility to be a closure. First of all, we create an outer scope where we have our router defined and injected. Then we have the inner scope that actually accepts the parameters that we were passing here. It now accepts the parameters and it can navigate with the parameters that it has been provided with. And that's it. That is done. Our utility function is now ready for use. Now let's see how we have modified our component to actually use the utility function. The first thing, we are going to be creating another member variable here that references our app router utility. You recall how we created results in the closure is the same. So we are creating the app router utility variable, and then this variable is what we will be calling here with the parameters that we just passed in. Okay, so when we click now go to profile, we should be able to navigate to our profile page, because we have solved the injection context error. Why? We have now created a context of our inject in the context section, sections that actually are like, so to speak, inject aware or inject safe. So let's test this out and see. We should now be able to go to our profile page after the countdown. And that's it. We were able to navigate to our profile page. So that's the first part. Now let's go over to the next part, whereby we will be using the validation token service within its own utility function. So let's get started. So for the second part, we are going to take a look at our profile component. Our profile component, it should display please wait, then after some few seconds it should display welcome back. So how are we going to do this? Using our validate token utility function. This is our validate token utility. As you can see, all we are doing is what we did before. We start by creating our variable here, the outer scopes variable. In this case, it's the API service. And if we look at the API service, it's just a normal Angular service. that has a validate token method inside it. And then here we are just mocking a latency from the server, yeah, whereby we are wrapping up the results in an observable, then we are returning the result after a timeout of 3000 milliseconds, that is 3 seconds. So in our validate token utility, all we have to do is to return a callable, and then this callable will give us the result of the validate token method in the API service once that API service callable has been resolved. All right, so let's take a look at how we are going to add this to our component. If we take a look at our profile component side by side with the HTML, we see this. We have this sentinel, or rather a variable that controls what will be displayed. In our case, we just had coded it to have a return of true, all right? So it's validating token. And then when we look at our HTML, we should see that we are wrapping up our results, or rather our display content, inside ng container. And what ng container does, it creates, like, for example, these two templates, they are going to be displayed conditionally based on the result of the validating token. So for now, all we are seeing is please wait, because we had coded it. So let's change this to false, and then we should see welcome to your profile. So what we want to do, we don't want to have this hard coded. So let's see how we can do that. One change that we have made is that unlike how we had it in the router utility, in this case, this check has to be made whenever the component initializes. That's why we have the call done immediately within this section here. All right, so this means that this will actually come here and call our validate token utility. Then a validate token will be called, the method in the API service. Then it will return the true. By default, it will start off trying to validate the token. That's why we have true returned. Then after some times, so this is just a mock from the backend. When the results are returned, that's when we say that it has finished validating the token, and then it should be false. So we are just going to be using this one. There are no changes made in the HTML, all right? So all we'll do is now use the result that had been now received from the validate token utility and drive now the UI. So if we reload our screen, we should see please wait. Then we should see welcome to your profile. So that means that the loop has been closed successfully. So if we do a quick recap, we open this utility, and then here we are going to call the validate token. Validate token will first return an observable value of true. Remember, we had hard-coded true before, so now we are not hard-coding it. We are actually using it in an actual like flow. And then we are now going to return a false one after a timeout, and that should wrap this section up. So I believe that's it, and I believe it's clear. So you have seen how we moved from closure from this simple example, all right, to actually having this work for us in Angular. So if you have any questions, once again, feel free to leave them below, and you can reach me out on any of the platforms, and I'll be more than happy to assist you. So always remember, you stop growing the moment you stop learning, and whatever you have learned, go further and teach others so that you can grow together. Okay, all right.